Welcome to video 3.6, multiplying polynomials. We're going to multiply polynomials by monomials today, and then we're going to take it one step further with multiplying binomials by binomials. Now this week you have learned what these polynomials, monomials, binomials look like. You have added and subtracted them, and now we are going further with multiplying them. There's going to be 3 examples, so make sure your notes are ready and you take each note step by step so you can refer back to them when you need to do these on your own and when the hot question comes up. So let's get excited. You know, I'm excited. This is my first video I'm making. Multiplying polynomials by monomials. We use the distributive property when we are multiplying each term inside the parentheses by the term outside the parentheses. And then you can just apply your rule of exponents to each operation. Now you guys know what the distributive property is. Whenever you see a term outside the parentheses, you know that you can just multiply by each term inside the parentheses. So you can just go like that and like that. And you can break it up to multiply by each term. We have plus 3x times 4. We're going to go through an example of that. But you can just see that we use the exact same things you did before, even when there were no variables attached to the monomial outside of the parentheses. And then below that, we have examples of multiplying a monomial by a trinomial. So trinomials just have 3 terms, as you guys know. So go ahead and get those notes down of what examples of multiplying a monomial by a binomial are and multiplying a monomial by a trinomial. So let's actually take a look at the second example. We have 4v times the quantity 3v squared minus 7. So what I'm going to do is break up the monomial by multiplying by each inside term. So we have 4v times 3v squared and 4v times negative 7. Now we know that our rules of exponents tell me that I have to add, I have a Ninja one, I have to add my exponents when they have the same bases, and then I also have to multiply my coefficients. So that gives me 12v, my exponents 1 and 2, 12v to the third. Moving over here, I just have 4v times negative 7, so that is negative 28v. So my final answer when I combine these is going to be 12v to the third minus 28v. Here we have a monomial multiplied by a trinomial. So we're going to do the exact same thing we did with our monomial by binomial, except there's just one extra term to multiply by. So we have 5p times 3p squared. Then we have 5p times negative 8p. And then we have 5p times 2. So we got to make sure that we multiply by each term in the parentheses. So 5p to the first power times 3p squared. Multiply our coefficients, that's 15, and p to the first times p to the second is p cubed. 5p times negative 8p, again we have our ninja ones hiding up there. We multiply our coefficients, so 5 times negative 8 is negative 40, and p to the first times p to the first is p squared. And then finally we just have 5p times 2, which is 10p. So this entire simplified answer, we cannot combine any more like terms, is 15p to the third minus 40p squared plus 10p. So now we're moving on to multiplying binomials by binomials, and we use a method called FOIL for multiplying these binomials. FOIL stands for first outside, inside, last. And that explains the order in which you multiply these binomials. So you start with your first terms, then your outside terms, then your inside terms, and then your last terms. So in this example, we would be multiplying our first 4r times negative r squared, then our outside terms 4r by negative 2, then our inside terms 7 by negative r squared, and lastly be our last terms, 7 by negative 2. So we're going to take a look at how we do this. And write down example 3, 4r plus 7 times negative r squared minus 2. So we've broken it down into first, outside, inside, last. Remember that stands for FOIL. So multiplying the first, we have 4r times negative r squared, which is, we have our Ninja 1 again, 4, there's another Ninja 1 right here, so 4 times negative 1 is negative 4, and then r to the first times r squared is r to the third. So our first term is going to be negative 4r cubed. When we look at the outside terms, we have 4r and negative 2. So 4r times negative 2. That is just negative 8r. Then we have our inside terms, which are 7 and negative r squared. So we have 7 times negative r squared. There's that Ninja 1 there. So we have negative 7r squared. And then our last terms are 7 and negative 2. So just 7 times negative 2, that's negative 14. So if I string these all together in the order that I did them, I have negative 4r cubed minus 8r minus 7r squared minus 14. Now I have to look and see if I have any like terms that I can combine, and I don't see any. So what I'm going to do is just put my final answer in order of exponents. So we'll start with my highest degree, which is the third power. So my final answer is going to be negative 4r cubed minus 7r squared minus 8r minus 14. And this would have changed if I had any like terms to combine, but since I didn't, we can just leave it at this in order of decreasing exponent. So your hot question is up right here. Find the product of this binomial times binomial and simplify your answer. So if there's any like terms to combine, make sure you combine them in your final answer. Also try the IXL skills AZ6 and AZ8 and get ready. And as you are doing this hot question, make sure you're giving yourself a little pump up, get excited. You're the man. You can do this problem. You can conquer this algebra. Enjoy. Tell everybody I'm the man, I'm the man, I'm the man. Yes, I am, yes, I am, yes, I am. Okay, I'm done.